Here we have a two-way table that has the class, freshman, sophomore, junior, senior, and the sex, female or male. Now I already have the totals out here written, so the total for each row, and then the total for each column for females and males. So take a minute and do that, and you can pause the video if you need to. We've previously answered what percentage of female students are seniors. So here we first consider the condition of being a female student, then we consider the number of females who are seniors. So if we look at the percentage of female students that are seniors, we look at the female students. There are 274 female students. Now we need to consider out of those 274 females who are now seniors. So we have 77 out of the 274. So that was how we answered that question. Okay, so now we're going to look at some notation. Probability of B/A represents the probability of event B given that event A has already occurred. So we read this as the probability of B given A. So we're looking at the probability of B occurring given the condition that A has already occurred. So looking at number 1, what percentage of female students are seniors? If we write that using conditional probability, so we want to know what percentage of females are seniors. So we're given the condition that we're starting with a female, and then we look at the seniors. So the way you would write that is the probability they're a senior given the condition they're a female first. Okay, so this is how you would write this question. What percentage of female students are seniors? Okay, so find the probability of male given they're a freshman. So here, under the condition that we have freshmen, so we're only looking at the freshmen. So we go to our table and look at freshmen. There's 120 freshmen. Now we want to know, of those 120, what is the probability now that they're a male out of those 120? Well, there are 56 males out of the 120 freshmen. Okay, so 56 out of 120 or 46.67%. Okay, so of course there is a formula for conditional probability. If we have the probability of B/A, so the probability of B given A, you take the probability of A and B divided by the probability of A. So just very quickly to show you on this, the probability of a male given they're a freshman, so looking at this one here, male given freshman, that's the probability of A and B. So notice how B/A, A and B. So the second thing in the parentheses is your A, so that's freshman. So probability of freshman and male divided by probability of A, which is, again, the second thing in the parentheses, which is freshman. Okay, so to actually find probability of freshman and a male, so you look at your table, the probability of freshman and male. To be a freshman and a male, you have to be one of these 56 people. Okay, so there's 56 male freshmen out of the 525. So that's 56 over 525. And then divided by the probability of a freshman. So when you look at the freshmen, there's 120 freshmen out of 525 total. So 120 out of 525. So now what you have is you have a fraction divided by a fraction. If you remember those math rules, when you divide fractions, copy, change, flip, or copy, change, opposite. So teachers will tell you different things. But you keep the top fraction the same, and then dividing turns to multiplying by the reciprocal. So you flip that bottom fraction and change the middle division here to multiplying. So you get 56 over 525 times 525 over 120. So that ends up giving you 56 over 120 because the 525s will reduce out to 1 over 1. So 56 over 120 is the same we had up here. Now you can see that using that formula can be kind of tough. So usually, in many cases, it's easier to find conditional probability by intuitively thinking your way through the problem. And that's how we're going to do them here in this video. Okay, so on the next page, in an upcoming primary election, a campaign manager wants to examine the support of an issue for their candidate. They take a poll of female Republicans and male Republicans, and the results of whether they support the issue are given. So we have male Republicans and female Republicans. Yes, they support the issue. No, they don't support the issue, or they're not sure. Now again, I already did the totals for the columns and the rows, and there's a total of 285 in the survey. So if one Republican is selected at random, find each of the following. So the probability of choosing a male Republican given they answered yes. So the first condition is that they have to have answered yes. So there's 148 yes answers. So we're only considering those 148 people. So out of those 148 people, now which ones are male? Well, there's 96 males out of those 148. Okay, so 96 out of 148. Okay, part B, the probability, they're not sure given they're a male Republican. So now the condition we're looking at is that they are a male Republican. Well, the male Republicans, there are 150 of them. Now, out of those 150, how many said not sure? There were 4 male Republicans that said they're not sure. So that's 4 out of 150. Okay, I'll give you a minute to try the next couple. Notice on these two, the words are the same, so the people are the same that we're looking at, except notice how they're backwards. Okay, so C and D are backwards, so pay attention to see how that changes your answer. Okay, so I'm going to show you the answers for those, but pause the video and try it. So, no given female. Well, there's 135 females, and there were 60 that said no out of those 135. Female given no. So under the condition they said no, there's 110 that said no, and there were 60 females that said no. So that's 110 in the denominator and 60 in the numerator. Okay, the probability they said no or they're not sure. So this is an or, that means you're going to add the probability that remember, we're only choosing one. So the one person you chose, they could have said no or not sure. So the probability of no, there's 110 no's. There are 27 not sure. So you would take the sum of those to get 137 out of the 285. Okay, the probability of a male or not sure. Okay, this one's a little bit trickier. In this last one, the no or not sure, there was no overlap. No, not sure are two distinct columns. So they are mutually exclusive, meaning you couldn't say no and not sure. The same person, they couldn't say both of those. So you add those together and you're done. Well, male or not sure, there's 150 males and there are 27 not sures, but there's 4 males that are not sure. So if you just took 150 plus the 27, the problem with that is you double counted the 4. You counted the males that are not sure twice, and you don't want to do that. So the probability of male or not sure, this goes back to that addition rule. It's not always clear when you use that, just looking at questions, but here's an example of where you use it. You add the probability of male plus the probability of not sure minus the probability that they are male and not sure, because you double counted them. And you end up with 173 out of 285. Okay, the last few questions. Now we're choosing 2 Republicans, and we're doing this with replacement. So we're going to choose the first person, put them back in the pool, and then choose another person. So you could, in theory, choose the same person twice. So find the probability they both said yes. So that means you need to choose a yes and a yes. So you look at the probability, the first one was yes. So there's 148 yeses out of 285. And then the second person will be the same probability. Okay, so 148 out of 285 times 148 out of 285 is about 0.2697. Okay, try the both female. It's a very similar idea. And I'll put the answer up there so you can see it. Okay, then the last couple. Probability they're both male who said yes. So males who said yes. There's 96 males who said yes out of the 285, and you have to do that twice. So 96 out of 285 times 96 out of 285. And I forgot to do the arithmetic on that, but if you do 96 out of 285, and then you just square that answer, about 0.1135. Okay, and then the last one. Okay, this one's a little trickier. So if you choose 2 people, 2 Republicans, find the probability you get 1 male and 1 female, and it can be in either order. So what that means is you can get a male then a female, or you can get a female then a male. So you have to find the probability of each and then add them together. So the probability of a male and a female, male first is 150 out of 285, times the probability of the second is a female, 135 out of 285. And then add, it's going to be basically the same number again. They're just kind of flip-flopped. Okay, so when you do that, you end up with 0.4986.